Yesterday, I also talked about a little bit of a trick with you guys that if you look for your largest intercepts to start with, it helps you with the scope and scale. Did that make sense as I was doing that? Okay. Looking at all of our intercepts there, obviously I'm going to disregard the negative x plus y right now, but the other two equations, 2x plus y, 4, and 2x plus y less than or equal to 13. Of those two inequalities, which one's going to be the largest intercept? 13. Excellent work, ladies and gentlemen. So if I know that's going to be the largest one out there, can I just place 13 here? Now to go along with the 13, that means that on the other side, if this was 13 there, this would be about 13 here. Just scoping it through. Now, wouldn't half of that be the next intercept for x? 13 over 2? Can I write it as 13 over 2, or can I put 6.5? Does it matter? Connect the dots. Inward or outward for this one? Does it go inward to 0 or outward? Inward. Okay. The next one has x and y intercepts at what? 4 and 2. 4, 5, 2 for x. So if this is 13, that'd be about 6.5. So a little bit here, maybe about 4. And then the 2, well, if that's 6.5, there's like 3-ish, so maybe 2 is about here. Just rough scaling. Connect them. So this was what, 2, 0, 0, 4. Now this one is moving outward, right? Bless you. So right now we have that stripe, if you will. Are we okay with that? Now, here comes what gets weird with that negative x plus y. We know that they both have to have intercepts at 0. But if you rewrite it in terms of x, in terms of y is greater than or equal to x, you get that. If you think about that in terms of just slope-intercept form, that just means y equals x. That means everywhere on the graph there's a slope of 1, and every ordered pair is the same number for x and the same for y, isn't it? So my best bet would just be draw this. Does that make sense? Okay. So, excuse me. Now I have to figure out what side to shade that on. Above that line to the left or below that line to the right are numbers bigger for y. Above and to the left, very good. And a really easy way to think about it is you can't use 0, 0, but if I use 0 and 13, is 13 bigger than 0? Yep. So I know I have to shade upward, which means I'm shading into this region here. Okay? So this is my boundary that I'm working with today for this problem. Okay? Yes, sir. What's that? This one right here? I got that line from this. I added x to the other side. Yep. Yep. I'm putting it in solving in terms of y, because by doing that, then you have y. And this is the one time I kept yelling you don't use slope-intercept form. This is the only time it makes any sense at all. When it's when you have it to 0. When you have it to 0. If that equaled 8, I wouldn't do what I just did. Since it equals 0, that means my intercepts are both at 0, and I can't draw a line with just 1 point. I need 2 points to determine a line. That's why I drew it like that. Clearer-ish? Okay. So now what I have to do is figure out the 2 points where it intersected. Since I know that x and y are equal to each other, if I'm intercepting into this line here, I would just say 2x plus x is 4, because y equals x. That means x is 4/3, which means y is 4/3. I get 4/3 for both of those. I do the exact same thing with the other equation. Since x and y are equal to each other, I know that 2x plus x is 13. which means x is 13 halves. I'm sorry, 13 thirds, which makes y 13 thirds. And it's okay that you get weird numbers. So those would have been the 4 ordered pairs that you would test. I wanted to make sure I showed you guys one today, or from the homework that we've had, that had that slope line of 1, so that we can see it again. Because we'll see one tonight. Just how everything builds together. Okay? Good times, right? What? Hey, these are all good times. These are fun. So let's start talking about linear programming word problems. We put the FU in functions. I wanted to do that for math team shirts, but I didn't think they would let that go. What do you mean? Oh, I don't know. I have no idea. I'm guessing that they're trying to get everybody shirts for going to the football game. That's my guess. I don't know. No. Sorry. Mr. Goff, the athletic director. I don't see. Does anybody know what's going on with those? Maybe on the athletic council or something? Really? That's cool. Somebody donated money to get everybody in the school a shirt. I don't know. Don't look the gift horse in the mouth. Anyway, I really like to start linear programming word problems with the filing cabinet problem. There's only 4 of them on here. Figure out which it's a number. It's one of the sides is the top problem that says something about filing cabinets. So when we start talking about this whole idea of linear programming with word problems, we have to take into consideration basically everything that we have done so far in this chapter. In this chapter, we have done systems of equations. We have done graphing systems of inequalities. We have done find maximum or minimum values from the graphs, from their shaded regions, given constraints. Now you have to read to come up with your own. The way that I always like to do these is to read the question and identify what your objective is to do first. Then you go back and figure out what other info did you have. So as we read this one, it says you want to buy some filing cabinets. You know that cabinet X is $10 a unit, requires 6 feet of floor space, and it holds 8 cubic feet of files. 3 things: money, floor space, volume. All right. Cabinet Y, cost. There it is again, money. $20. 8 square feet of floor space. There we go. And holds 12 cubic feet of files. Volume. You have been given $140 for this purchase, though you do not have to spend that much. Which means, can you spend $140? Can you spend less than $140? Yes. So that would be, is that a less than or equal to $140 or greater than or equal to $140? See, this is how you're getting the words out of this. Then you've got the office has room for no more than 62 square feet of cabinets, 72 square feet of cabinets, thank you. How many of which models should you buy in order to maximize storage volume? What's your objective? Maximize storage volume. So in this problem, there was something about storage volume. It said cabinet X stored this much, cabinet Y stored so much. That's your objective function. What's the objective? Maximize storage. We wrote objective functions. They were written out as a C equals something. The two things they're talking about, X's and Y's, cabinet X, cabinet Y. Put away the computer, we're not using it. Thank you. Cabinet X, cabinet Y. In the problem, you read through, you look for cabinet X costs $10, 6 square feet of floor space, holds 8 cubic feet of files. Isn't that volume, cubic feet? So for every cabinet X, how many cubic feet does it hold? So if I bought 3 of them, how many would I have? So what did you do between those two numbers? Multiply. 8 cubic feet of cabinet X plus how many cubic feet of cabinet Y? Good. There's your objective. You've taken care of your objective, so I cross it off in my words. I don't go back to it because I've already eliminated it. My objective was to maximize storage capacity. Storage capacity is dealt with in volume. Okay? Now you have constraints. You were restricted by the amount of money that you had and the amount of floor space you had. How much money do you have? 140. We already said that you can spend up to and including $140. Each cabinet had a specific cost to it. How much did cabinet A cost, or X cost? And Y? So isn't that just 10X, 20Y? Has to be less than or equal to $140. Pulling the information, pulling the restriction. I took care of money. So anything that deals with money now, I had this, this, and this. Those are gone. What numbers are left? Your floor space. How much floor space were you restricted by? Can I use all 72 square feet? Can I use less than it? Yes. Up to and including 72 square feet. How many square feet did the cabinet X use? 6, and then the other one was 8. And you're all done with that. You're all done with that. Can you have negative cabinets? No. No. Do I have to write that down? So what quadrant is this? First quadrant. Are you wrong if you put that down? No. Because in your mind, you should realize that now you're dealing with actual physical objects. You're not going to have negative value. So it has to stay positive first quadrant. So what do you think we're going to do to start with? Draw the first quadrant. Okay? First quadrant problem. Of all those intercepts, you guys all agree that there's 4 separate intercepts there? I have an x of 14, a y of 7, an x of 12, and a y of 9. Which one was the largest? Which y? Okay. Well, which one is the largest number, though, out of all 4 of those? Let's try this again. What's the x-intercept here? 14, 7. This one is 12, 9. Which one? 14 was the biggest number. 14 then goes on the x, correct? Since I'm saying x and y, we keep x's to the left and right, y's up and down. I'm going to place 14 out here. And I know that if I space it kind of the same way, I know that it would be about there-ish. That way I scope and scale it. So if my first intercept was at 14 for x, I know that that equation or that inequality had an intercept at what for y? 7. So it should be half as far away, right? So if I'm saying this was 14 this way and it's about that much that way, I should probably place it about here. There you go. Works for me. Label it, connect the dots. What question do you think we have to ask now? Correct. Does it? Does it go, so I'm sorry, does it doesn't go through the origin, so now do I say inward or outward? I graph towards the origin. See how all of this is coming to this problem. Everything we've done for the past 2 weeks is built to this. Intercepts in the next one is at what? 9 and, 12 and 9. So 14's here on the end, 7's about here, which means 12 is about here. Okay. 9 is above 7, in case you didn't know. I know sometimes math is hard. Did that go through the origin? So, inward or outward? Inward. So now you have your shaded region. You're moving inward here. So I'm looking now at that spot, which means I have to find that point. That point is where our two lines intersect. Which means we just have to solve the system of equations between here and here. Yes, sir. Those are the only two lines that I have. Oh, you just have to follow through. You have to, the thing that gets tricky with some of these things, if you've got 4 equations, sorry, if you've got like 4 equations, go back and look at the intercepts of what you have. That way you can figure out which equation were you dealing with to give you those intercepts to set those two equal to each other. To figure out which ones you have to solve for. Because if you go back and you were looking at this guy here, we knew that that intersected that line because I knew that the intercepts were at 2 and 4 here, and it intersected this line, so that's why I set those two and worked with it. Then I looked at this one with this one because I was looking at my intercepts. That way you know which one they are. If you want to label which line you're graphing, that's fine. Nope. All right. Now, when I get to this one here to solve that equation, that system of equations there, there's a bunch of different ways of doing it. In my mind, I think the easiest way is to just divide the top equation by 10. If I do that, I get x plus 2y is 14. And now what am I going to do? Substitute, yeah, bring the 2y over and use substitution. This is a case that substitution works really quick. Could you multiply the top one by 6, the bottom one by 10, eliminate the x values via subtraction, and go on your merry way? Absolutely. But if you see something that's easily divisible to get one of the variables by its coefficient of 1, substitution is always a nice little trick. Okay? There's no right or wrong way to do it. You just have to do it. All right? So that means that x would have to equal 14 minus the 2y. Substitute in. All right. Okay. So let's see. 6 times 14, 84. Is it 84? So we got 84 minus 12y plus 8y is 72. Is everybody okay with me just doing all the algebra in one step here by moving a bunch of stuff around? 12 equals 4y. You okay with that? Combine those, you get negative 4. Bring that over, you get 12. What's y? If y is 3, very good. You just substitute back into what you did. You have an ordered pair now where those two intersect, bless you, at 8 and 3. Yes, ma'am. If you didn't buy any cabinets, would you maximize your storage capacity? You're right. It's kind of a, you don't need to worry about that. Okay, now you're getting a little too technical. This is situation. Hold up, guys, hold up. Well, in this case, the question is asking us to maximize our storage capacity. You don't have to even worry about finding it out. You don't have to do that. And that's where a lot of these questions will ask you. Sometimes it might ask us, what's the minimum amount you have to do? What is the maximum amount you have to do? That's why identifying the objective is the important part to do first. So our objective was what? Way back up here, I had 8x plus 12y. We have ordered pairs of 0, 7, 8 and 3, 12 and 0, and obviously 0, 0 won't get us anywhere. So 8 times 0 plus 7 times 12 is 84. 64 and 36 is 100. And then that was 96. Which of those numbers is más grande? Que bueno. Is that cien? Cien? Is it cien or ciento? Cien? Cien. Necesitan 8 cabinets de J y 3 cabinets de Y. This means your answer. Oh, do you get 8? 8? Yep. And that's where it comes back into labeling stuff out. The next example I wanted to walk us through is when your labels aren't X's and Y's. How do you differentiate between what you're working with? And that's usually what most people have problems with. Okay? So in this case, I think it asked you, the final answer was how many of each do you have to buy? Your answer would be 8 cabinet X and 3 cabinet Y. Now, flip over to the other side. On the bottom, they're talking about snack bar. Okay? It sounds so excited. I don't know, it's just like. So I have the snack bar. And I wanted to make sure to talk about this example because it doesn't say cabinet X or cabinet Y. So you kind of figure out where you're going to place things. So first things first is always to read. Oops. You're at a snack bar, and it cooks and sells hamburgers and hot dogs during football games. To stay in business, it must sell at least 10 hamburgers, but cannot cook more than 40. It must also sell at least 30 hot dogs, but cannot cook more than 70. I've never said that these were practical, I'm just saying that they're word problems. The snack bar cannot cook more than 90 items total. They're running short on propane, I got nothing. The profit on a hamburger is 33 cents, and the profit on a hot dog is 21 cents. How many, hold on, I don't know, it doesn't say, but how many of each item should it sell to maximize profit? If it doesn't matter what you're selling them for, because if you're only making, if I'm selling them for $2, that means I'm buying them for $1.67. I'm making for a hot dog or for hamburgers, I'm only making 33 cents profit. So you don't have to worry about costs in this case. Now, if it was thrown in there, you only have $1,000 to supply your stuff, and you sell them for a certain amount, then you know that it's a different type of profit. Here it's just profit on the burger. How many of each item should it make a maximum profit? What's the objective? Maximize profit. So we start with our C function for our maximize profit. I make 33 cents. Now, here's where you have to start kind of guessing how you want to label. Hamburgers, hot dogs. They both start with an H, right? Can I say burgers and dogs? Yeah. It's fine. It's fine. I will say one thing. A lot of times when people change the letterings on these, you'll flip-flop something. So if I stay with the idea that I have 33 cents per burger plus 21 cents per hot dog, there's my profit. And it's funny, when I was working on these problems last night, both of our boys were doing their homework. Our oldest was actually doing his math homework, and our youngest was actually, he was doing it too. They were doing number bonds. And he's like, Daddy, what are you doing? I'm like, I gotta do my math homework. And I was doing some of these problems. At the same time, we were grilling hamburgers. So I'm like, so there's that. Burgers. You have a boundary of amount of burgers you have to, the minimum amount of burgers you have to cook, and the maximum amount of burgers you have to cook. What's the low end on the burger? 10. I have to cook more than, but I can cook 10. So that's it. So my lower boundary is 10. My upper boundary on burgers is 40. I also have to do the same thing with the dogs. What's the low end on the number of hot dogs you have to sell? And the upper end? Okay. The snack bar cannot cook more than 90 items total. Now, 90 items total, is that a combination of both burgers and dogs? So if I cooked 89 burgers, how many hot dogs would I have to cook? One. Obviously, it wouldn't work with our parameters here. So if I cooked 10 burgers, how many hot dogs would I have to cook? 80. Still didn't work in our parameter, but you get the idea. So that means burgers plus dogs have to be less than or equal to. Now, can you have negative hot dogs and hamburgers? No. Plus, we know that can't happen because your low end is 10 and 30, isn't it? Okay. Now, in this case, barring any major catastrophe, nobody's strong-arm robbing the concession stand where you're only making 33 cents a burger. You must have a horribly high overhead at this point. Of our three restrictions, our three constraints, what's the largest x and y intercept? Yes, sir. 90. So I'm going to place my 90s first, but here's what I'm going to do. What comes first in the alphabet, burgers or dogs? Burgers. Anyway, so what comes first in the alphabet, x or y? I'm going to put burgers on the x, dogs on the y. That's why when I'm trying to come up with ways of labeling stuff, I try to put them into some sort of an alphabetical way. That way I can say X and Y. That's just, in my mind, how I've always thought. Yes, that's fine. But I will suggest to try to keep them with some sort of a way the words are given to you. Because I have seen this numerous times. You'll accidentally call one X and flip it to the other problem and call it Y. Okay, for some sort of a constraint. It happens all the time. But if you keep saying burgers and dogs, I know that I'm looking for all the info about burgers, looking for all the info about dogs. So let's see here. I have 90s as my outer points. So put 90. Inward or outward? Good. Okay. Burgers. Between 10 and 40. Well, what's halfway of 90? 45. So it's pretty close-ish to halfway for 40. So I say about here-ish? Sure. Whatever. This is how you learn how to scale this. What's half of 40? What's half of that? So if I guesstimate that halfway is about here, another halfway is about here, I call that 10. I'm going to. Okay. You can't stop. Now, I do the exact same thing with the 30 and the 70. Again, 90's at the top, halfway is about 45. Come down a little bit further, you get about 30, right? Because halfway would be 22. So half is here, that's half, 30 here-ish, I guess. Sure. There's 0 and 30. Actually, probably want to put that a little bit lower. That's better. And then halfway between 30 and 90 would be 60, wouldn't it? So that means 70 has to be a little bit above it. Halfway. Now, I'm going to take that graph and just put it on a single page real quick because it's easier to see it larger than it is on the dual page since we've taken care of all of our stuff. We know that our parameters are within here. And then I have these 2 points to worry about. Okay? Are we all right with that? I'm just going to blow it up so you can see it better. So, horizontal line through 70. That horizontal line through 70 intercepts the line that had x and y intercepts of 90. X plus y equals 90. So if this is the y value for 70, what's the x value have to be? X plus y equals 90. 20. Okay. If this was the vertical one that was 40, that means the x value was 40. 40 plus what is 90? 50. It's really nice when it's vertical and horizontal. Okay? Those are the first two ordered pairs. This one is 40 and 30, because that's horizontal. This one is 10 and 30. And this last one would be at 10 and 70. Really, really, really nice when it's horizontal and vertical. Because you know that your verticals are your x coordinates, your first term. Your y's are your horizontals, your second term. So if I take this back to a smaller picture, the horizontal line through 70 intercepts that line that x plus y was 90. So the horizontal is the y value, correct? X plus 70 equals 90.
Oh, okay.
Okay, I'm using that system of equations with just direct substitution, which is really nice when it's horizontal and vertical. It's really easy then, okay? So now you've got your 5 spots. 10, 70, 20, 70. And we're going to substitute into our profit. Also, by putting burgers first in my objective function, I know that that's the first column of information in my ordered pairs. Dogs being second, it's the y value in my ordered pairs. Now, this one had a bunch of decimals in it. I heard it half of it, even though I did 60. 10 and 70, this was 18. 20 and 70, $21.30. Ooh. 40 and 50, you're going to make $23.70. Cool. 40 and 30, you make $19.50. And then at $10 at 10 and 30, you make $9.60. I know. Well, again, remember, if you're only selling up to and including 90 items to start with, you're probably dealing with a small amount of people that are hungry. That's possible as well. They might have, it's all supply and demand. So in this case, it tells us that you need to sell 40 burgers and 50 hot dogs to make a profit of $23.70. Take that to the bank. Hey, you know what? And then if you think about it, if you really want to get into the idea like overhead and all that, paying employees. Maybe it's already built in. Maybe it's already built into their costs. Actually, they could be volunteers, you're right. Other side, bottom, football and soccer. Other side, bottom, football and soccer. Read that one real quick. Football and soccer are always good. Must be nice to have rich family members. So Josh has it made. You know. Well, think of it this way. Maybe Josh was a kid that just liked to be inside all the time and want to play video games. They're bribing him. So Grandma and his uncle are bribing good old Josh to get outside and do some work. Go run around and be a kid. So as you read this, what's the objective? Max amount of money. In the problem, it talks about him making money. He makes money from two sports, football and soccer. Which one comes first in the alphabet? Football. This is American football, not football. Because I know then you're like, wait, is that the same? So, can we say that he is playing, how much money does he make for playing football? $3 for football. And how much money for soccer? $4. Okay? There's your objective. Make as much money from Grandma and Uncle Bill. He could be the kicker. Anyway, going back into it, what's the first constraint you see? Maximum of 15 hours, right? So between the two sports, he can't practice more than 15 hours, right? Which is, you just said it, F plus S has to be less than or equal to 15. What axes do you think I'm going to put the F on? Because it comes before. There's method to the madness, I'm telling you. Eventually you're like, what's the next one you see? 2 to 5 hours of soccer. So soccer is bound by 5 hours on the high end and 2 hours on the low end. Okay with that? Yes, sir. Yes, sir. Okay. If you said the most, maximum means the most you can do. If I said most I can do is 15 hours, can I go more than 15 hours? Is 16 smaller? So if the most, I'm gonna get my wallet. The most this key ring can carry is 5. Can I put more than 5 on it? No. Can I put less than 5 on it? Could I put 5 on it? Yes. So the most hours. There's always one. Every so if you want. And then anyway, what it means is you can go up to and include 15 hours. Can't go beyond that. That's the maximum. The highest amount you can get to is 15. So it's everything up to and including 15. Could you practice them both for 6 hours? Can I practice them both for just 2 hours if I wanted? Can I go up and practice 18 hours? No, you ran out of time. You only have 15 hours total available. And then lastly, I think there was one more, wasn't there?
Yeah.
All right. Bless you. He wants to give at least as much or more time to football than soccer. Yes, sir.
Is it x is less than or greater to y?
For what I just said?
Yeah.
Okay. So are you saying X is football?
Yeah.
Okay. So you're saying football is less than or equal to soccer? So he wants to give at least as much more time to football than to soccer. Yeah, football is greater than or equal to soccer. Yes, you just said it backwards. You said S was less than football, which is fine. But so football was greater than or equal to soccer. I think you said soccer was. I think you said it was soccer was less than or equal to football. I might be wrong. Now we did one like this earlier today, where you have that would be a case where you have both interceptions 0, isn't it?
Yeah.
Okay. So I want you to finish this one, and then these. No, not yet. Don't worry about it. So, what I'd like you guys to do this evening, I want you to finish the one we just did. You've got your constraints, you got all your stuff, you know how to draw that out. But on the sheet that I just gave you, I want you to do number 1 and number 2. They're talking about airline seats. Or I'm sorry, one's airline seats, the other one is tickets for a play, dance. All right, so finish this one. The numbers 1 and 2 on the other one. Airline tickets and dance company, or airline seats and dance company tickets. Then we will continue on a few more. Just the one we were working on. Don't worry about the top one and the other one where Betty's doing something. We'll probably look at that one tomorrow. Yeah, just